Hello and welcome to ACBS-Toronto Winter Workshop 2022. After another year of uncertainties, we are doing a virtual winter workshop again. So welcome to our second annual virtual winter workshop. During our filming, you'll probably see the motor that we pulled out of this boat a couple of weeks ago. It was a balmy minus 28 that day. I was glad that we got it over and done with quickly. The motor is being donated to a custom engine build. We're doing an inboard 4.3 for a nice big 26-foot Duke. So you'll, like I said, probably get a glimpse of that in amongst the things that we're doing in the shop today. Well, 2022 has brought us a good old Canadian winter with lots of cold temperatures and lots of snow. So let's head on inside and start the winter workshop where it's nice and warm. We're here today at Kent Allison's shop in Westwood, Ontario, just east of Peterborough, for Wood with Dwight. Dwight Boyd's going to do a segment on abrasives for us today.
Hi everyone, welcome to ACBS Workshop. Today we're going to talk about a rather mundane subject, sandpaper. A few weeks ago we were hanging around my shop with the good old boys bending elbows, and someone asked me what was my favorite tool. I thought and I said, sandpaper. Well, I got a funny look. They all laughed, but I said, no, consider this. From the start to the finish of any boat building project, restoration project, whatever it may be, the tool that you have in your hand more often than any other is sandpaper. Right from the very beginning, for taking rough edges off frames, you will use coarse grits, right through to final finishing, right through to varnishing. Different grits, different types of sandpapers are used. So let's call them abrasives. What are they? There's all kinds of them out on the market. There's garnet paper, there's flint, there's ceramic paper, there's silicone carbide paper, and aluminum oxide paper. For the most part, in our boat shops, aluminum oxide is the paper of choice. It has a sharper grit, cuts faster, and lasts much longer, and is easily available. Most of the others do not apply to the kind of work that we do. And as far as garnet paper is concerned, I don't know why they make that stuff. So typically we would start with some of the papers. We look at our sandpapers and we see numbers on the back. Well, what do these numbers mean? 80 grit, 100 grit. Grit is defined by the size of the particle that will go through a screen 1 inch square with 80 holes in it. So if it has an 80 aperture, 80 hole pattern, and the grit goes through it, that's 80 grit sandpaper. A tighter screen, 100 grit sandpaper, finer particles. And as the numbers increase, you can go all the way from 40, which is more gravel paper than it is sandpaper, all the way on up to the more commonly used 80, 100 grit, 120 are the most common ones you'll have in your hand for the most part. But when it gets finer, you can go to 220, 320, 400, 600, 800. When you get into finishing, 1200, 1500, even 3000. And I'll give you a look at some of these papers. I don't know if we can sort of get a pull in on these or not. But these are two examples of 800 and 1500. And with these fine papers like this, the difficult part is telling which side of the paper has the grit. You can go all the way to 3000 grit. Now this is for polishing. When you're going to get into buffing and polishing, you'll go with these. So you're not going to use these very often. So let's stick with the more common ones. Sheet goods are the most common, and they're used typically with various sanding blocks. I've seen on YouTube, it's really kind of amusing. I've seen someone take a sheet of paper, fold it in four, grab it and start scrubbing away at some piece of wood. Well, all he's accomplishing is wearing out his paper because you've got grit on grit. There's no backing there to flatten the surface. it's ineffective. Some of those are entertaining. You need blocks, a backing for all of your sandpapers. Most blocks that you can buy, first of all, are very expensive in some cases and useless in others. These are common. You've seen these in Canadian Tire. Auto body repair places supposedly use these. I don't think so. And you cut your paper and you clamp it in there. Well, what happens is you can't get the paper tight. And unless the paper is tight, when you do this, the paper stays attached to the surface and the block moves inside of the paper, so it's not very effective. So take these and they have a place in the wastebasket. Other blocks you can buy commercially, long boards for example. There's a really nice long board. I think they're available with a very hefty price tag, probably goes somewhere around 80, 90 bucks. Well, I bought this when I was young and foolish. You don't need to spend 90 bucks. You have scraps around your shop. Make one. And there is nothing more than offcuts from your shop, a bed put on it, and you have the same thing for probably $3 worth of scraps and a little bit of your time. Very effective. Sanding blocks, different sizes. Make your own to fit different sizes. You might think that these are small, but you'd be surprised. They're really effective when properly used. You're going to find concave surfaces on a boat that need to get in there nice and gently. Well, obviously hard blocks don't work. Scrounge around. This is heater hose, available at any auto body shop. Various sizes, sold by the foot, flexible, soft surfaced, and you can wrap your paper around that and work in concave surfaces. If just the hose is too flexible, put a piece of pipe or a dowel down the center of it. Now you have a solid concave, convex, one of the cons, sanding block to use on those surfaces. Different sizes, very effective. To hold your papers onto a block with the sheet goods, it's fingers tight holding it onto the blocks. Yes, that works. It's very effective. The best methods are the hook and loop, Velcro. Stick it on, stays there. And the advantage of those is that, first of all, they stay on. And when you are working with the tool, when you move the block, the sandpaper moves as well. So it does the job. With every motion, you're doing work. The paper's not sitting there and the block moving over the paper. That's the problem with these ones that clip on the end. You can never get them tight enough. So for long blocks, long boards, you have a variety of grits. 60 grit paper for some of the early rough sanding, you know, to 80 grit or 100 I brought this case. Again, same thing. Quick change. Saves you an awful lot of time in the shop. Right down to finer grits. What have we got here? 320. This is pretty fine. This you might start early, or in the early stages of finishing, to use grits like this, and they can go even finer. Other sanding blocks, for example, here's one that we use in finishing. It's a piece of foam, sponge, has a hand loop on the back, and is flexible. Now what this is best for are the Velcro back. So if we're working with 220, for example, in here, then there's a quick change, quick on and off. And the advantage of using this kind of a flexi is if ever you're using, nope, I don't have it this way. If you're sanding a rounded surface like that, especially when you're into the finishing stage and it's delicate with the first few coats and you don't want to risk burning through, a hard block is going to present a hard surface, and put high point loading on spots, and the risk of burning through is high. Whereas with something as flexible as that, you can grip it and you've got control of sanding around convex, concave, con surfaces. Like that. If this is still too stiff, then we have softer ones, Velcro backed. So we would put the softer one on there. Get the right side, the softer one on there, and then your paper on there. Now you have a very soft block for doing rounded surfaces. Let's call them rounded surfaces, it's easier. But where do I get Velcro stuff like this? Making your own blocks. This is Velcro back. And this is the hook part of the hook and loop. 3M produces the hook portion in rolls like this. So all you need, in fact, is a roll. I think this is a 4-inch. They also make it in a 3-inch. So you can buy a roll like this. Now, most supply houses where you would get these papers would be an auto body shop, Supply, the UAP Napa. Local hardware stores just don't deal with this kind of stuff, so you have to search it out. Chances are they're not going to stock this, but they can order it for you, or possibly online. So you need a roll of this, a can of contact cement, and you can make any type of Velcro backed sanding blocks, be it from little blocks like this to longer boards like this to fairing the edges of a plank. If you're got a long edge and you want a nice sweet swoop with there, make one. Can't buy this, you have to make it. Piece of, in this case, it's a piece of white oak, and it needs a backing. So there's a rubber back. I've scrounged up some rubber somewhere. It's fairly hard. You glue that to the oak, and on top of the oak, cut this to the appropriate shape, glue on the Velcro. Buy these sheets, cut to the appropriate width, put it on, and it's flexible. So it'll take the convex and the concave of a plank. Handier than a shirt pocket. Same thing for final fairing when you want to really get that deck perfectly fair and the hull perfectly fair. Make a longboard. Again, in this case, it's 5/16 marine grade mahogany plywood. Strong, stiff, flexible, takes curvatures, and you can work a deck and get that perfect fair. And same on the hull. Can't buy these. Make them. You've got a piece of scrap plywood around the shop, certainly. Pieces of mahogany, chunks like that. This is rocket science. Roll of this, can of contact cement, longboard. Shape, size, anything you may want. You can get little pads like this, which again are Velcro backed. A good option is scrounge up a old inner tube. It's rubber, you can cut it to shape, and again you can apply it to the block surface with contact cement, and now you have, that one's got Velcro, now you have a block, it's a well-worn block, but with inner tube on it. This is actually sticky back 8.5, 11 foam sheets from a craft store, believe it or not. It's about a 1/16 or 2 millimeters thick, 4x8 sheets, cuts nicely, sticky back, put it on, and it's just the perfect surface for sanding blocks. If you want something softer when you're making a sanding block, what works extremely well are computer mouse pads. You can get them from 1/4-inch neoprene or thick material to thinner to very thin mouse pads. They offer you different thicknesses, different densities, and they make great pads for sanding blocks. And those pads make a big difference in the ultimate finish of your work. Cut angles on your blocks so you can get into tight spaces, like underneath that windshield. You can cut them on angles so you can get into that corner. Velcro backs, make your own blocks. You don't have to spend big money to have all the proper sanding equipment that you really need. This is very important, this hook portion of the hook and loop. So we have different shapes of sanding blocks, whatever you may choose to make. So now we need to get our sandpaper to fit properly. If you have sandpaper of any amount in your shop, you have to have one of these. Excuse me. A sandpaper sheet ripper-upper. Homemade, best tool in the house that helps you control the size of your sandpapers. Simply made from a piece of plywood, a piece of any wood, mahogany happens to be, and an old hacksaw blade. The board is marked off in half, third, and quarter low sheet. So that would be in landscape mode. It's also marked off in half, third, and quarter in portrait mode. So when you line up your sheet, and we're doing it in portrait mode, and we want to rip it in half, we would align it with the half in portrait mode. Like that. And it's as simple as that. Now we have a half sheet. Now we want to cut this in half again, but now we're moving to landscape mode. And here I said this was easy. There we go. Move to landscape mode, and it's down here. So we'll line up to the landscape half. And once again, perfect quarter sheet. Now I didn't bring one, but if you have one of those quarter sheet orbital sanders, which are a miserable tool at best, this fits them perfectly. If we want to do other sizes that are going to fit our blocks, well, we've made our block to fit that sheet appropriately. So then we want, well, maybe we're going to go with half sheet again in portrait mode. Now we have a perfect piece of sandpaper that fits our block. Very important, very handy tool. Never mind the scissors or the utility knife, or make one of these, they're handy. Okay, and one more thing, one more little trick that I'd like to leave you with, and this may seem a little bit minor, but believe me, it'll serve you well. There are going to be times when you can't use a block and you can't use a machine, and you have to get in there with your fingers. That involves small pieces of paper and hand sanding. Now, when you start with a small piece of paper, some people fold it in half, like that. Problem with that is when you put the paper down to do work, the backing, paper on paper, slides on itself, and the grit doesn't go anywhere and doesn't do any work. The way to avoid that is to take your small piece of paper, and this is small, but it's a good size, and you fold it in thirds. 1, 2, 3. So now, with thirds, you don't have a grit on grit, you have a grit on paper. And when you go sanding, the paper moves. because the grit is on the back of the paper and not grit on grit. The real plus of doing it in thirds is that when this side wears out, you flip over to the other side and do some more. And when that side wears out, you expose the inner side and you work some more, thusly giving you 100% use of your paper and zero waste. And I particularly like zero waste. Thank you very much for watching.
Now here's Jeff on mechanical with a look at an antique transmission.
So here we have the drum from the inside of the transmission. This is the key part of your transmission for drive or propulsion. So in this case, when the engine's rotating, this component here, the drum, is what transfers your power from the engine into propulsion through the drive shaft and the propeller to make your boat go forward and backwards. So what we're going to start with in this is the friction, and the friction is a combination of these brass components, which we're going to replace with new ones over here, and steel plates, and then we have the outer pieces here, which are also a cast steel. And basically we're going to stack these plates in alternating from brass to steel, starting with a brass one in the drum to start. And I left a brass unit over here, and you can see the little holes that line up with what you can see in the drum, just so that you could see where we're going to start. Now, once we stack these in and we set the drum, this is what creates your forward friction. And how it's done is mechanically by hand, and I'll show you this later. You squeeze the drum together, and what it does is it takes these components and squeezes them tight together so that they grab, and that allows the power from the engine to transfer through into the drive shaft. Another key component when working with these vintage transmissions is to remember that they share the engine oil, and that's how they're lubricated. So the oil pan is open to the housing, and they all use the same oil. So adding a friction modifier to your engine oil, such as Slick 50 or some of these fancy synthetic additives, adversely affects your friction plates, because it modifies the viscosity of the oil, and these plates here rely on a thin layer of oil between them to lubricate them. And when you squeeze the drum and make them grab, you want a specific viscosity of oil. And if you look in your manuals for most of these vintage boats, it's 30 weight or 40 weight SAE oil. Anyways, I'm going to start putting some friction in, and I'll show you a little blurb along the way. So as you can see, our first piece is in. Now I'm going to take one of the metal frictions, and we're going to add that in, and they just lay in and drop in. And we're going to do that so on and so forth until we get to the last piece. The other thing I will do is I will put a slight amount of oil in between each plate as I'm assembling, so that when it starts up it's not dry and does not stick together. Here we're going to stack some more plates in. Again, a little bit of oil in between the plates so they don't get sticky. This engine is up for assembly in the next week, but it could be a couple of weeks before we get to fire it up, so we don't want these things getting stuck while we're still in the process on the actual engine. On a side note, those brass friction plates, which you can see in the drum now, we were unable to locate them anywhere, so we actually had them made. Okay, here's the clutch pack and the drum stacked in. The next step will be to put the drum together, which involves taking this piece here, and it goes on here, and it's threaded on the outside, and we will be putting this together. Before I get too far, I need to assemble this piece here. This is what actually shifts, so the shifter actually grabs it and pulls it up or down for forward and reverse, which this is what applies pressure to the clutch pack for the pinch to make the friction hold. So once you've got this wound in, they should be locked. These three pieces should be locked into this. And as you can see, I can move it, but I can't pull it out and lock it. Often I get asked, how far should I spin this in? It is a very difficult piece to judge until you've got the transmission assembled and you've got the shifter hooked up. But you should not be able to pull this and engage it and make these cam over by hand. Even with two hands, you shouldn't be able to. So I've set the drum, and now we're going to install the locking pin. And the locking pin goes in this threaded hole here, and it's a special bolt. So this bolt, as I'm going to bring it up here, it's got a step or a pin in the end of it. This particular transmission also had a lock washer. We're going to install the lock washer, and then we're going to install this in here. Now when we do, keep in mind that in the transmission housing there are notches or holes inside the drum, and we have lined this up so that this pin will drop into one of those holes and lock the drum together so that this does not spin. So essentially at this point, I'm not going to tighten it. I'm just going to spin it in until it locks in, and now I can't, you can hear it. It's locked in and it can't rotate on me. And we'll tighten that later when we go into adjustments once we've got it all set up. Beside the drum we have the reverse band. We're not going to put that on at the moment, but the drum actually slides inside of that reverse band, and that's what, when you squeeze that, it stops the revolution of the drum and then turns the internal gears. I'll show you this stuff in a little bit. Now we're going to work on the housing. So what we're going to do is, I have this housing that's all cleaned up. Again, this particular transmission is off of Buchanan Junior 4. If you want a comparable, this would be similar to a Chris Craft Model B. Some slight differences in components on the exterior, like this housing and the lid are aluminum in the Buchanan and quite often cast steel in the Chris Craft. However, today we're going to start, we need to install this bearing into the housing, and then we're going to push that down in and put a gasket on it and put the cover plate that holds it. So this basically goes like this and holds it in. This is your coupler that adjoins to your drive shaft. It actually fits into that bearing, and that's your support at the end of the transmission. And then the shaft on the drum comes through, and it's keyed in with a nut here and the lock washer. So I'm just going to do some quick assembly and show you what it looks like. Okay, we've put the bearing into the housing. It went in fairly well, just a light tap, and it seated itself. Now we're going to put the gasket on and the outer housing. Now a couple of points here. These particular mounting holes are blind. In other words, they do not go through to the other side of the case. If they went right through, I would suggest using some sort of thread sealant, but because they're blind, it is not a necessary item because they don't go through to the other side. This particular transmission had lock washers on the bolts on this housing. We're going to reinstall them. Again, not all do. Some of them have a star style and some have a flat washer. These ones did, so we're going to put them back on. And keep in mind our hardware. So these are original bolts, and if you can see on the end here, you can see the symbols. I like it during a restoration, if we can, to use the original hardware. It just keeps it more authentic. However, like any other restoration project, most of the time is in the cleaning and the prepping. So all of the hardware has been through a tumbler and it gets wire wheeled and everything gets cleaned and checked, and lots of time there, and the assembly at the end is just the fun part. So I'm going to go in here now and I'm going to install the gasket and the end housing with those bolts. Before I do install the end housing, however, we are going to install the seal. The seal goes around the coupler, and that's what holds the oil inside the transmission. So I'll install that into the end plate and then we'll put this together. So here's the end housing assembled and the bolts have been torqued down. Now, one question I get quite often is gaskets, and should you use sealer or should you not use sealer? I'm going to say that that one's open for discussion based on application. In this instance, I did not put any sealer on this particular gasket. The bolts are blind holes, so they don't go through, and there was a large mounting surface. And to be perfectly honest, our gaskets technology today is far superior than it was when this engine was built, and the likelihood that this gasket leaks is probably nominal. There are other applications throughout this engine build where we will use some sealer to either hold a gasket in place or to produce a better seal. In this instance, it did not seem necessary, and it also helps on the restoration to keep it look a little more authentic and neat and tidy. Some people get excited and put a little too much gasket sealant on and then it oozes out, and in this instance this transmission housing is likely not going to get painted but maintain its aluminum finish, and it would look terrible with some dark brown gasket sealant drooling down the side of it. Next, we need to install the drum and the reverse band and all the shifter linkages into the housing and make it all as one unit. This can be one of those tasks where you have space for one hand but you really need three. It can be a bit tricky. I'm probably going to film it in stages where I show you pieces, and rather than my hands in the way where you can't see anything. One of the other components that was actually manufactured for this were the shift components here, these bronze pieces. These were actually remanufactured. They will wear and cause problems or break, and Antique Marine had them made. So this is a new set that we're putting in this particular transmission. Before we get too far, we had to install this plate and these two keyways in before we slide them into the housing. You'll see why in a moment. There's just not enough room to work around that. They get buried in the bearing. There's the drum slid into the housing, and as you can see, this washer and those two keyways are no longer accessible, so we have to do that first. So now that it's sitting in here, I'm going to take a couple of minutes and start putting the shifter pieces in, and I will film it again once I've got those pieces installed. Here we have the shafts started into the housing. And the brass piece here holds a cork gasket underneath it. I have a couple other ones here I can show you. I'm sure these cork gaskets seal against the housing. They're pretty basic, and they seal against the shaft. I have elected at this point to put the coupler into the end of the housing to help secure the drum so that it's not as sloppy when I try to put the shifter pieces in. One thing that I do when I'm putting these together is the keyway here. I put a little bit of sealer on the keyway. I'll show you what it looks like. So there's a little bit of sealer, and when I push it on, it will seal around the keyway. The other thing I am going to do is put a slight amount of grease on this surface where it runs in the seal, and that will help slide it into the seal, but also if it sits for any length of time, when we do the startup, it won't be dry and it won't burn the lip of the seal. Here's the coupler installed and the nut tightened. Here's the start of the shifter being put together. We've got most of the components in, and if I grab the shifter lever, you can see that things move. Again, I've got everything snug and with new components. We have to get everything worked in. Okay, now we've got the shifter in, the reverse band, and the linkages set up. You can see that we are trying to make this as tidy as possible, but you can't get your hands in there and video at the same time. So that's what it looks like when you've got the linkages together. Here we are assembled. I won't take it any further today. You can see a couple of bolts missing in the housing. I'll wait until this is assembled onto the engine so that I can check the shifter linkage. Right now, when I try to shift it, I have a piece of pipe that I put over the shifter to simulate the length of the handle of the shifter at the front of the boat. However, it's really hard to hold the transmission and run the shifter by yourself. It's a whole lot easier when it's bolted to 600 pounds of engine. So I'll do the final setup on the shifting positions once it's installed on an engine. But this is a bit of a wrap up on a Buchanan Junior 4 transmission assembly. I hope you enjoyed it, and we'll bring you some more stuff soon. Since the mechanical transmission that we just built is really hard to show you a test on, I thought we'd switch gears here and go to a hydraulic transmission and do a test for you and show you how we test these after they've been built. As you can see, I have a rubber hose looping it there. That hose normally would be line in and line out to a cooler to keep the transmission fluid cool. This unit will have its own fluid, unlike the engine and transmission combination that we just built. This is also a hydraulic shift, so you shift this lever back and forth and it hydraulically shifts the gears. There is a tool you can see there that I've built to do testing with. It comes in real handy these days when you're finished doing a build. It's nice to test to make sure that you've got forward and reverse and no leaks. So on the end of these hydraulic transmissions is the pump. And you can notice when you take a look at this that there's directions. So it shows up for right-hand rotation, which happens to be the engine that this transmission was for. If it were a left-hand rotation, you actually rotate that whole pump assembly 180 degrees, and instead of up for right hand, you spin the pump around and it'll then say up for left hand rotation, and you can see the arrows embossed right in the end of the pump housing. So this is how you determine your direction of flow through the transmission for shifting and giving you your forward and reverse. So it was quite ingenious to use the same pump just in a different direction. Now, this is a drive plate that I've taken out of an engine core, and quite often in our industry, if you can't find it, you have to make it. So this is the tool that I use with a big mixing drill to spin the transmission to create hydraulic pressure so that I can test the transmission not only for forward and reverse direction, but also for leaks. So here's another view from the side. You can see that I've put a piece of tape on the output shaft coupler so that you can see it move. I've got my tool installed onto the drive or the input side to the pump, and now I'm going to install my drill onto the end of it, and I will start the drill, and you can see I am spinning the pump, and you can see the output shaft actually spinning. Now keep in mind, I have to spin the drill in the proper direction to get this to work. If I spin the pump backwards, it will not create pressure or flow. In this case, you can see I just shifted it into reverse and the tape is going in the opposite direction now. And then if I flip it into forward, you can see it goes in the opposite direction again. So this shows me that I have multiple directions, and I apologize, it's a little difficult to do by myself here, but I was showing you that it does have a neutral and that we do have a forward and a reverse. So next time I'll incorporate a cameraman to make this a little bit more harmonious. So there you have it. This is how we would test after a rebuild to make sure that everything's assembled correctly and that we do have flow, that we have forward and reverse in the transmission, and that we don't have any leaks at our input or output shaft seals or any of our gaskets. It's much nicer to do it now on the bench than get it in the boat and then realize you have a problem. So I thought I would just show you again from a different angle. You can see the drill and the drive plate in the background spinning, and that I have both directions going here. So again, these tests are important from my standpoint so that I can confidently hand this back to the customer knowing that the transmission is working properly and that they'll have an install and ready for the water. So again, the hydraulic transmission, it's a little bit different than the mechanical in the way that it shifts. We could have done this by running an engine with the mechanical transmission and shifting it back and forth, but I thought this would be a quicker way to show you how we test transmissions. I hope you enjoyed it.
Hi, I'm Mike Gridley and welcome to my boat shop, or the other half of my garage as the case may be. Last year, for those who watched the first virtual winter workshop, you might recall that I started part 1 of the restoration of this boat. This year, we're going to carry on with part 2. Well, I'm glad that is behind us. That was one big mess. The amount of time it took to grind everything out of the interior, plus clean the shop up, was a lot longer than I thought it was going to be. I think I spent more time cleaning than I actually did doing the grinding. Now, we've cleaned the boat out with soap and water. We'll clean it again before we lay any resin into the boat with MEK or acetone. But what we're going to start next is to put the core back in and rebuild the first part of the hull. Checkmate is like so many boats. It's the old original balsa core. So it's balsa wood set on its end grain, laminated together, and of course attached on a mesh back to keep it all together. Allows it to fold, and of course you can cut it wherever you need to along those fold lines to fit the area you're working with. This one's got a few awkward shapes, so it's going to take a little time to make everything fit. To bond the core into the boat is a bit of a two-step process. First is to make up a standard mix of polyester resin with the MEK hardener at a ratio for the particular brand that'll do a slow cure. You want this to stay wet, so when we put in the second bonding mix, it's all going to adhere together. So the whole area where it's going to get bonded into is coated with the polyester resin. And of course the back side of all of the individual pieces is coated as well. This makes everything as extremely waterproof as you possibly can, so this is never done again as a full rebuild. And to make sure that the bond is going to be as strong as possible. The second part is to take the same polyester mix and blend in micro balloons to make a thicker paste that's going to fill all the voids. And using a spatula or spreader, fill the entire area in preparation for placing the pieces in. A bit messy, but when you get the pieces in, you have to use a roller to lay them all down and then weight the areas and give it 24 to 48 hours for everything to cure. Now once the bond is cured, you remove the weights and of course coat the top side with the mix of resin and catalyst hardener. Next process is to fill in the gaps all around the balsa core that we've put back into the structure of the hull. Now we want this to be a strong fillet, not just one for aesthetics. So we're going to use, instead of the balloons, we are going to use chopped cotton. Now the cotton makes a stronger bond that is structurally more sound, and that's what we're aiming for here. The mix is going to be the same. We're going to mix 4 ounces of resin with the 4 milliliters here of the hardener, and to make that a little easier, I've pre-measured an amount using a syringe on this cup so I can mix batches quickly as I work on the project. So next, got to mask up and get the ventilation going. When mixing the putty together, you have to work fairly quickly because the catalyst goes in before you thicken it, so that's properly mixed. And you've got to work quick getting the chopped cotton into it. What you're looking for here is a blend that's almost like a smooth peanut butter, maybe a little on the side, so you're going to be able to get it in to all of the voids. To get the mix to flow into all of the spaces and voids, I'm using a straightforward auto body flexible spreader that you can purchase at any auto supply store, and that helps push everything down to make sure there's no voids. You're going to have a good bond that's waterproof. While I was waiting for the final setup on the bonding for the core, it was time to clean up the transom. It was badly damaged and weakened and cracked, and part of it had to be cut out to get the well to release when I took the deck off the boat. So there's a lot of work and a mess to make back here. So out the garage door, all that fiberglass went. Back inside the shop, the next task was to do the detail grinding and sanding required before the transom could be installed. Next task was to use my laser level so I could do a nice straight line to clean up the skin from where the well had been bonded to the skin and had to be cut up to remove the deck. So this was just marked out and cleaned up with a saber saw. And of course, a couple of quick passes with the grinder to clean up the rough edges, and the skin was going to be ready for the next steps. Now it's time to get started on the first real major structural component of this rebuild for the Checkmate, and of course that's the transom. Now what I've purchased for that is marine grade mahogany plywood. Now I've seen lots of projects online where somebody's gone down to the local lumber yard, just purchased straight up construction plywood, and even put it together with just PL adhesive. That is not the way to go. You've spent this much time and energy, it's worth a few dollars extra to do this properly. Now the reason you want to use marine grade plywoods, and this is mahogany, there are other grades as well that cost a little bit less, but the fact that there's no voids. You notice when you look at a normal sheet of plywood, you see the knots on the surface, but you also see the dark spots where the voids are in the lamination of the plywood. Marine grade plywood, you will find no voids that are going to trap moisture. Also, they use waterproof glues and resins. This is not going to come apart. Unfortunately, in a lot of construction materials, the glues and the resins are not waterproof. So this is a pretty major component because I'm putting an inline 6-cylinder, 115 horsepower Mercury back on this boat. I want to make sure it's going to be structurally sound. To create the transom that's going to be the correct thickness of about 2 1/4 inches, of course, 2 layers of the mahogany plywood are going to have to be bonded together. So here's the process for doing that. One of the first things was to pattern out the required chopped matte fiberglass that would be part of the bonding setup between the 2 layers. After that's ready, again, it's just a straight mix of thickened epoxy, so we've used some Catasil to thicken it up a bit, and of course the catalyst, and it has to be rolled out completely to wet this first surface, and then of course all of the chopped matte fiberglass has to be thoroughly wetted out on both sides to create a strong bond. Next step again is to thoroughly wet out the second sheet of plywood to make sure it's fully waterproof and of course is going to create the strong bond that's required. Once that is all done, it's a simple case of clamping the 2 sheets together with the resin and fiberglass mat in between that creates the super strong bond, and set it aside for 3 or 4 days to make sure the whole assembly cures. Now just working on the final fitting here for the template that we're going to make the transom core out of. And we have a little bit of slack here on either side. So what I'm going to do is mark it. I'm going to go plus an inch here, plus a half, plus a quarter on that particular side. And on this, I'm going to go plus a half and plus a quarter here. I'm going to make it a little bit fat, and I can always trim it back. I can't add back on. Well, in fairly quick order, I was able to transfer the outline to the assembled pieces of plywood for the transom and take on the long, slow, tedious task of cutting it with the jigsaw. Now this is going to take some time to cut. There's one reason they call blades consumables, and you better have a lot of spare blades for your saw, because the fiberglass really dulls them quickly, and it takes a few to get through on this. There we go. In the boat, not quite perfectly. So this is where the fun's going to start, with a little trimming, a little sanding, maybe a little router work on the edges to get this to drop in exactly where I want it, so that it's ready to bond into place. Now the reason I'm first routering this edge is to make a nice curved radius that matches the curve of the fillet between the floor, or the bottom of the deck, and the transom itself. So this will snug in around all of that and make a tight fit square up against the skin. Now it takes a little patience here. I went back and forth multiple times with the plywood for the transom, putting in place, checking the fit, coming back, grinding off a little bit more so that this was going to set in as best as possible. Well, I've got everything set up here so we can talk about what the next steps are here when we're putting the transom in the boat. So what I've done is put the transom into position here, and as you recall, this is 2 layers of mahogany ply with a layer of fiberglass mat bonded in place, and everything was clamped together, and we're using polyester resin in there to make the bond. Now when we're going to put this into the boat, of course we're going to put up another layer of fiberglass mat, going to use the resin to get that into place and let it start to set up. Then we're going to put in a layer of the bonding putty that's going to really hold this in position, and use these really cool clamps. What we have here are some automotive scissor jacks that have been welded to the tubes, and a series of hinges and pads set up, so when you open up the jacks, clamps down and makes a great job of squeezing this and attaching it to the fiberglass skin. And just in case I have a few loose spots, I've pre-made up some boards, some self-tapping screws and washers that I'll treat with some oil, drive it through the skin, and bring everything together. In bonding the plywood into the transom, the first step was to pattern out some fiberglass chop mat to create the first layer in the layup. Now, with any of the fiberglass work, lots of resin has to go in to make sure the cloth is thoroughly saturated and there's no dry areas whatsoever that will weaken the bond. So a little bit of patience, brush and a roller, and it's all set. One thing you will notice if this is your first time working with fiberglass, especially this matte which is just loose pieces of fiber compounded together, is it tends to sag and shift and stretch when you try to work with it. So it takes a little bit of patience to get it laid into the area. And then of course with all fiberglass cloth layouts, you've got to use a roller. Takes a little bit of time to get all of the air bubbles out, make sure there's no voids, and of course squeeze out the excess resin that you don't want either. Now here's a little tip to speed up some of your work. If you know, fiberglass resins can be controlled in their cure time based on temperature and humidity, and adjusting the catalyst, the MEK hardener that goes into the blend. I kicked a little more into this so it would cure faster, so about an hour after I put cloth in, I was able to trim it up and get ready for the next step. Well, with all the prep work done with the skin inside and out, it was time to put on the bonding putty to put the plywood into place. Now you can mix up your own bonding putty. There's plenty of recipes that you can find for the mixes online that use a variety of cabosills, microballoons, and other fillers. But it takes some time, and it gets a little bit on the expensive side and tough to get the exact ratio. So in my case, it was a lot easier just to buy the putty in a gallon can, mix in the hardener, and apply. Well, when you're putting the plywood in place, you just have to set it up against the skin and wiggle it around several times. What you're trying to do here is make sure you've spread a good contact area of the bonding putty onto the back side of the plywood. Press everything into place as best you can, and of course, next step, apply the clamps. Now what I haven't shown here is, yes, I did apply the boards and screws to the outside of the skin to make sure everything was going to pull in tight. Then I moved on to putting in the fillet with the same putty all the way around on the join between the hull and the transom plywood. Well, after a few days, I removed the clamps here that were holding the plywood transom up against the skin for a nice tight bond between the original fiberglass outer skin and of course our new transom. Now with the clamps out of the way, the next thing I tackled here was to take some of the same bonding putty and do a nice fillet all the way around on the inside edge between the hull and the transom. Now this provides a nice curved radius, so when you're laying in the fiberglass cloth, it curves up nicely. No right angles, which causes fiberglass strand to break and would weaken the transition from the hull to the transom, which is something you don't want to do. And before I do the fiberglass cloth work and resin, which is going to be to do the floor, to do the transom, I thought I'd make up a few extra pieces. So what I wanted to do was make up the single stringer that goes up in the center of the boat. What I've used here is a few scraps of wood, some pine I had around in the shop to lay things out. And I'm fortunate enough to have a laser level, so I was able to level the boat side to side as well as bow to stern for a normal attitude and pull a line center and side to side. And using these scraps of wood, I'm able to tell, number one, what the depth has to be here for the stringer, and as well where the contact points are going to be with respect to the floor. Now this is really simple structure. What we've got is just the stringer, and of course the plywood that's going to go in for the deck is also going to act like a bulkhead at this point. There's also a forward bulkhead ahead of the helm that has to go into the boat. So with the laser set, what I'm able to see here is what I'm looking for a start all the way through on the boat is a 3-inch depth and 8 feet long for the stringer that's going to go into the boat. Now I'm going to leave a gap here at the transom. It's not going to bond straight in to the transom. That allows me some space to mount a block of wood to put the bilge pump, so I'm not screwing down into the balsa wood. And again, it'll be a little bit shorter for the bulkhead on the front, but that gets me started with the rough cut to be able to position it.
I hope you enjoyed the presentation and picked up a few good tips along the way that'll help you with your fiberglass boat restoration. As you can see, the Checkmate's almost complete here, and it's going to be in the water this spring. So at a future date, we'll bring you part 3, which will bring the conclusion of the restoration to you.
Okay, thought I'd get you caught up on what's going on in the shop these days. We've got a few things getting close to getting wrapped up. This here in front of us is a Buchanan V8. It was a 283, 185 horse. We've substituted the block and heads for early 70s 350. A little bit of performance stuff. We're hoping to squeeze it up about 100 horse. As you can see, it's got, you know, some shiny chromy sporty stuff. We've got the chrome alternator and the valve covers. We got performance wires and coils on the external. It is running a Paragon transmission, and we've got a custom black metallic paint job on it. It's kind of a cool one. It's going in a gentleman's racer. And then behind it we have something you probably haven't seen before. This is a 4.3 liter GM, and it has been built into an inboard, so it's kind of unique. GM and Volvo and Mercury didn't offer this combination. We've decided to build one. The transmission's a Borg Warner. It's actually off a Chrysler. The bell housing's a V8 Mercury. The block and heads are off a Volvo Penta. The intake is Mercury, the exhaust is Mercury, and the ignition's Mercury. And we've done some custom work. I'll get around the other side and show you what we're doing for water draw. Anyways, we'll just come through here, and then I'll show you that, and we'll come back to these guys here. So on the front, we went more like a ski boat style, crank-driven water pump, and we're going to feed the system that way. And of course, it's going in a wooden boat, so we decided to do a custom collar on it. So I slide by here on the bench. There's a Junior 4 transmission. Just going to redo the back seal. Other than that, it's rebuilt, ready for the next engine project. It's coming our way. Over here we have a Buchanan Junior 4 full restoration. This is a collaboration with Patrick Keefe at Antique Marine. So we are just wrapping up. We were test running it yesterday and today, and we're going to call it good here, and the customer is going to receive it this weekend. Beside it we have a Chrysler 318 polyblock, late 50s, early 60s. It's out of a Shepherd boat. We did a bit of a custom color on it. I really like this color. It's kind of a spin-off of the actual Chrysler blue. It's got a metallic in it. We're just waiting for the decals to come back from the shop that's reproducing them for us, but everything's rebuilt, water pump, everything's ready to go on that one. We just need to do a test fire. Over here we have a Chrysler Crown that's in process. Chrysler 6-cylinder. This is actually in a ditch burn. I believe it was probably a 4-cylinder boat originally, but we are just in the detail stage on this, and then it'll go into test fire, but it's starting to come together. Just waiting for the cap and rotor and I've got to rebuild the carb, but the kit hasn't come in yet. So this one will be finished up here hopefully shortly. In behind it, Gray Marine 140. You can see in the background the pistons. We're in the quote process on this. It came in, tried to make a little more horsepower. We've decked the head a bit. It does have the high compression head. We were going to do a custom grind on the camshaft, but found a few other things, including some marks in the pistons and the cylinder bores that we weren't thrilled about. So we're just going in the process of searching and destroying on parts and then quoting this job. And then in the background here, just about ready for paint, are a couple of big block Chryslers. They're a pair out of a boat. There they are. As you can see, they are factory twin 4 barrels. And if I go here, there you go, Riva Special. I believe these were in an Aquarama, and they will be going back in. We're doing factory colors on this one, trying to keep them pretty original. I just have the balancer and a couple of brackets on the front to do before we put them in the paint. I think this is a 27-foot Aquarama if I'm not mistaken. So there's a few things going on in the shop. Like everywhere, never enough space, so many projects, and space is always of a premium. But we're happy to be busy, and we're enjoying some of the cool projects that we have this year. So hope you enjoyed the quick little tour, and we'll have some more stuff coming. There's a triple carb Chris Craft yet to be built this year, a couple other Buchanans, big block Chevy, so we got some cool stuff coming. Hope you enjoyed it.